Autonomous braking system, a system that can be used for all vehicle with little modification. Abstract the major reasons for vehicle, car, bike, truck, etc. Accidents are sudden appearance of obstacle while driving. The response time of drivers is different for everyone and varies person to person in such a panic situation, and stopping distance varies. Some leads to accident and some prevailed the accident, but of course with serious damage. This project will help us to decrease response time by helping the driver while driving to stop in time or to minimize the stopping distance to prevent the collision. The distance between the vehicles or moving vehicle and the obstacle can be detected by using ultrasonic sensors. We can also install a system that can communicate between vehicles to determine the gap between vehicles, i.e., approaching vehicles either from front or back. Further commands can also added to help while driving. An autonomous braking system is an intelligent mechatronic system, includes an ultrasonic wave emitter provided on the front portion of a car producing and emitting ultrasonic waves. An ultrasonic receiver is also placed on the front portion of the car, operatively receiving a reflective ultrasonic wave signal. The reflected wave, detected pulse, gives the distance between the obstacle and the vehicle. Then a microcontroller is used to control the speed of the vehicle based on the detection pulse information to push the brake pedal and apply brake to the car stupendously for safety purpose. The use of computer or ECU, electronic control unit, is a major step towards improving the safety and performance of vehicles as well as driver safety. In this paper we have investigated one of the aspects of braking system. The design exercise is based on calculation. This paper illustrate the problems involved and future scope for intelligent braking system. Introduction. Braking system is an essential part of any automobile. It is used to stop at desired position or slow down whenever and wherever driver wants. Sometimes while driving suddenly a car comes in the way, stop, or a person suddenly came in front of vehicle. These situations are unexpected and based on driver's expertise he/she might be able to reduce the damage to minimum. To prevent such kind of accidents and to save driver's as well as others' life, autonomous braking system will be helpful and can create major impact on safety as well as driving experience. So, we developed a system which can be developed further to improve efficiency. Our system includes an ultrasonic system which gives the location of a particular thing in front of the vehicle, which then can be compared with tables and act accordingly to the conditions mentioned. The system is controlled by the microcontroller, Arduino Uno, which in turn controls the linear actuator to move the brake pedal. Components of automatic braking system. This system includes parts from braking system plus additional components like microcontroller, Arduino module, sensors, ultrasonic sensor, LiDAR sensor, proximity sensor, camera module, power supply for microcontroller, batteries in case of automobile. Arduino Uno. The Arduino Uno is used as control unit which senses the obstacle in front with the help of ultrasonic sensor and sends a signal to linear actuator, which then applies the brake to stop or slow down the vehicle. Ultrasonic sensor. The HCSR04 ultrasonic sensor is used to sense the object and gives the approximate distance of the object from the vehicle, which is then compared with the help of control unit. Linear actuator. A linear actuator is used because of its simplicity of use as well as space. It is connected to the brake pedal directly and it is activated as per instructions from the control unit. 2. Design procedure. A working of braking system. The automatic braking system is Arduino-based mechatronic system. Ultrasonic sensor and camera sensor are used as input sensors, continuous data collector of the surrounding, for the microcontroller of the system. The working of system start as the engine starts. Ultrasonic sensors and camera sensors start collecting the data as well as transmitting it to Arduino to take necessary actions. The car will be running without interruption till any obstacle comes in the way or passes near to the vehicle. When any obstacle comes, the sensors will detect that and passes the information to the microcontroller, and Arduino will take action to bring the vehicle to halt or slows down as per the requirement. Flowchart of the process. Figure 1, Flow. The breakdown of the process is 1. Firstly, sensors will collect data of the surrounding and passes data to the Arduino Uno. 2. Arduino will process the data and compare it with the program, safe distance. 3. After the comparing is done, the Arduino will be taking action according to the actions decided for the different situations. A. No action taken. B. Car will slows down done according to the distance between the vehicle and obstacle ahead. C. Car will come to halt. B. Safe distance and braking distance calculation. To calculate the safe distance, we first need to find braking distance. Braking distance. Braking distance is a distance a vehicle will travel before coming to rest after brake is fully applied. There are many factors involved in braking, like friction between the tire and the road surface, weight, wind, type of braking system, air resistance. But the braking distance is further divided into two parts: 1. Total stopping distance, 2. The reaction distance. Reaction distance is the distance covered before the brake is applied. Basically, it is the reaction time taken by the driver to apply the brake. Calculation is divided into two parts. Reaction distance is proportional to speed, car's running velocity. Reaction distance is product of 1. Reaction time varies according to the situation. There are 3 situations: 1. Expected, 2. Unexpected, and 3. Surprise. Reaction time is different in different situations. For expected, it ranges from 0.7 to 1.0 seconds, for unexpected it ranges between 1.25 to 1.5, and for surprise it is 1.5 to 2. Since we are calculating for an accident or a probable collision, therefore, it should be surprise situation reaction time, i.e., 1.5 seconds. Here, in the work energy method, the braking distance increases 4 times as speed doubles. The braking distance by this method is high as compared to kinematics method. Safe distance. Safe distance is a distance between the vehicles or the obstacles in front of our vehicle. It is programmed in the microcontroller to avoid accident and collision. If any obstacle comes close and cross the limit of safe distance, the Arduino starts alerting the driver. If driver don't take any action, then the Arduino will take action and apply brake according to situation or slows down the vehicle. Safe distance is decided as per the vehicle's speed. Safe distance varies for different speeds. Safe distance for 20 km/h is 17.20 m as the speed is slow, and other factors like friction, air resistance, weight helps to stop the vehicle within the limit. As the speed increases, the vehicle gains momentum, and to counter that, safe distance should be more like for 60 km/h 80 to 90 m. Similarly, for high speed 100 km/h or above, the safe distance should be 130 to 140 m. This was for dry roads condition. For wet roads condition like rainy season or any fluid or liquid is spilled on the ground, to counter that, safe distance should be more. Even for low speeds it should be more. For 20 km/h safe distance will be 20-25 m, for 60 km/h safe distance is 75-80 m, and for high speed 100 km/h or above should be 150 m and more. Safe distance should also vary with different situation of traffic, like in traffic jam where the vehicles moves but the distance between the less, like just 1-2 m gap, may be less in some situations. We can add traffic feature in the program to avoid the false alarm situations that can damageable to both the vehicles moving close and can also affect the traffic, or it can create another traffic jam. See calculation of force required to brake pedal. In automatic braking system, braking is an autonomous factor going to work independently of driver, and this is done by Arduino, which is taking decisions whether to brake or keep going without slowing down or slow down to prevent collision. This can be done, 1. By adding a linear actuator near brake pedal or wheel to brake directly, 2. Adding a high torque DC motor in combination with brake pedal. We are doing it by linear actuator as it is more precise and easier to use in the system. Linear actuator is controlled by Arduino to brake accurately. The force required to actuate brake must be equal to human force or greater than the human force. 5. The force required to brake is calculated as 4 Conclusions. Autonomous braking system helps to avoid accident and it is effective in braking works as co-pilot. Having Arduino as ECU, electronic control unit is very helpful. Survey says the cars with autonomous braking system have low accident rates compared to the cars those don't have. Ultrasonic sensor works perfectly and can be effective future also. Response time was good enough avoid the critical accident and minimizes the effect. This braking system can be used in all type of vehicles. Autonomous braking is significant because it not only helps in reducing road casualties but it is also leads a path to achieve complete autonomous driving. One thing that can be improved in the current version is that we can increase the sensing range of the vehicle by fitting more sensors as well as add the speed sensor to make the vehicle stopping dynamic or by using some type of sensor/device, LiDAR or camera, which can be used to better understand the vehicle's environment. With the help of machine learning we make a system which can also predict the path or if any sudden changes that can comes in way of the vehicle, the system can act on its own and find the best possible solution for that particular situation. The same things can be utilized for accelerators as well as clutch pedals to control the vehicle autonomously in a most efficient way, i.e. we can reduce the fuel consumption, engine wear etc. by controlling the engine speed with the help of linear actuators. Cost addition will be worth as it can save life. Provision can be given to disconnect the braking to driver to avoid confusion. Speed and acceleration measuring devices can be used with ECU for automatic braking at higher speeds. The braking system can be turned off to ride safety in traffic jam and avoid any type of confusion in braking and for others' safety.